Okay, let's talk about substituting in order to solve a system of equations. Two equations like this is called a system, and the majority of the time they make for two lines where there's an intersection, and that is the solution. So we're looking for that point from these two lines. The method of substitution is to figure out what one of these variables are based on the other, and then plug it into the first one. So I see a couple of possibilities I could do. I'm going to take advantage of this thing, the fact that here I have a single x all by itself. That one's not really a single y because it's a negative 1 times y, but here's a single x. If I subtract 3y from both sides, I get x is equal to negative 3y minus 6. This is the same as x. So what this means is I can take this and I can plug that into this equation where there's an x, because it's the same x. If we're looking for the place where these two meet, it's the same x and the same y for both of them. And to find out what that x and y is, we're going to take what this x is. We don't know the number, but we know what the x is in terms of y, and we're going to plug it into that. 2 times x. This is x. So 2 times x minus y is equal to 9. So now we do the normal math stuff that it shows. It shows here to take this and distribute, because that's what you do when you have a number in front of parentheses. Makes it negative 6y minus 12 minus y is equal to 9. I have two like terms on one side, so all I do is I combine them together. It gives me negative 7y minus 12 is equal to 9. Now we'll do the two steps to isolate the y. We'll add the constant that's next to it. Negative 7y is equal to 21. And divide by the number that's multiplying to it. So y is equal to negative 3. We now know the y value. Now we need to find the x value. And you can take that and just plug it into one of these. I like to put it into one of the originals. So I'm going to put it into the second one here. X plus 3 times negative 3 is equal to negative 6. So x plus, whoops, that's minus 9. 3 times negative 3 will be minus 9 equals negative 6. I'll add 9 to both sides, so I get it x is equal to 3. So that's my answer, but remember I have to put it into coordinate point form. That is the point where these two lines meet, at 3 and negative 3. Next problem, we're going to do the same kind of thing. No, this is an alternate method. In the alternate method, what we're going to do is we're going to take advantage of the fact that y is the same as y. They're both equal to y. I'm going to solve these both so that they are in y equals mx plus b form. So here, if I move 2x over, negative y equals negative 2x plus 9. If I divide by the negatives, I get y is equal to 2x minus 9. So here is one of the equations. Now I'm going to take this one, and I'm going to move the x to the other side by subtracting x from both sides. And then I'm going to divide by 3. So I get y is equal to negative 1/3 x minus 2. Interesting. So here what I have are these two equations. Okay. So what we're going to do is figure out from them, or put them together, shall I say, figure out from these two what the x and what the y are. This is y and this is y. If y is equal to y, this y is 2x minus 9, and this y is negative 1/3 x minus 2, and they're supposed to be equal to each other. You can also think of it as this y is equal to this, so we're going to come down here and plug it in for this y, so we get the equation like that. Now all we have to do is solve it. Okay, and the first thing to do is when you have a fraction on either side, multiply everything by that denominator. It's not the only way to do it, but I like to do this in order to simplify this so I don't have any fractions. So I'm going to multiply this side by a 3 and this side by a 3. 3 times 2 is 6x. 3 times negative 9 is negative 27. 6, negative 27, that looks right. When I multiply 3 times negative 1/3, the 3's cancel. So I get just a negative 1x, or negative x. 3 times negative 2 is a negative 6. So now I want to put all these together. Let me add the x's to both sides. And that gives me 7x minus 27 is equal to negative 6. Now I'll add 27 to both sides. And I'm going to get 7x is equal to 21. And when I divide by 7, I get x is equal to 3. And now I can put that back into one of these, such as here. So I'm going to get 3 plus 3y equals negative 6. Subtract 3. 3y is equal to negative 9. And when I move it so you can see it. When I divide both sides by the 3, I get y is equal to negative 3. So it's 3 and negative 3. That's the same answer for this problem, same answer. But it's a slightly different substitution method. If you already have the equations given to you as the slope-intercept form, simply putting them together is a very good start. Or you can do this method where you take one of them and substitute it for the other one. Or one variable, substitute it for the variable in the other one. Okay. Here are some other practice problems with it. This one's easily set up with two y's in it, where you can do one of those two things. You can make it both of them equal, y is equal to, or you can substitute one. I'm going to take this one and subtract 2x, so y equals negative 2x plus 2. Subtract 2x, that looks right. And I know that's y, so I'm going to put it in here. 4x plus, I guess I'll do this, negative 2 plus 2 equals 12. Now, I'm adding, but not multiplying anything here, which means I will not end up needing these parentheses. I'm going to rewrite as 4x minus 2x plus 2 is equal to 12. 4x take away 2x is 2x plus 2 is equal to 12. Subtract 2 on both sides, so 2x is equal to 10, and divide by 2, so you get a 5. Now let's put that into one of these. I'll take what I think looks like the smaller and easier one. So fx is 5, and 2 times 5 is 10. Subtract 10 from both sides. Y is equal to negative 8. And that's it. I have negative 8. So my actual answer then is to put it together into coordinate point form, 5 and negative 8. And I'm done with it. I have found the place where the two lines meet. If I graphed it, I would find that would be the place. Now there's this one here. And again, it lends itself to using one of them. Here I had a choice. I could have made this one y equals negative 4x plus 12, or y equals negative 2x plus 2. I could still do that with something like here, but I'd get a fraction. This one's all set up very easily to add 2y on both sides. So what I get is x is equal to 2y minus 3. And that's what x is, so I can plug it right in here and use it. Plus 5y equals 24. Distribute to both things inside it, 3 times 2 and 3 times negative 3, so that's 6y minus 9 plus 5y equals 24. 6y plus 5y is 11y minus 9 equals 24. And now we'll add 9, so we get 11y equals 33. Divide by 11 and we get y equals 3. And now we want to plug that back in. We should plug it into the original one of these, so I'll put it here. X minus 2 times 3 equals negative 3. Put it back in for that y. X minus 6 equals negative 3. We'll add 6, so x is equal to a positive 3. Negative 3 plus 6. So that x value comes first, then the y value. In this case, they happen to be the same number. And sometimes that will happen. That's not necessarily unusual. But you'll get something where you'll end up with the same number like that, and that's okay. It's just coincidence in this case. Sometimes, like another problem was 3 and negative 11. You can check these, by the way, if you want to be sure, by putting them both in. Here's a method of checking that's worth knowing. If they're both 3, put a 3 in for the x and 3 in for the y, so I get 3 minus 6 equals negative 3. 3 take away 6 is negative 3. That checks with that equation. Now I'll put it in here. 3 times 3 is 9, plus 3 times 5 is 15. And that's supposed to be equal to, or is it equal to 24? Yes, it is. 9 plus 15 is 24. So if you plug those two in here, you get the fact that both the statements are then made proven to be true if you use 3 for the x and 3 for the y.